Hello, this is the second video of the Hyperbolic Functions 1 series and looks at solving simple equations using hyperbolic functions. Simple equations involving hyperbolic functions can be solved by substituting their definitions, as seen below, in terms of e to the x and then manipulating the resulting equation. There can be more than one way to solve equations containing hyperbolic functions, and in later videos we'll also consider the inverse hyperbolic functions as a different method. Rewriting cosh x equal to 3 in this first example, we can see that e to the x plus e to the minus x over 2 equals 3. If we multiply up by that 2 and then also by e to the x, we would obtain a quadratic equation in e to the x. With a little rearranging. We can solve this by completing the square, or another method. So, completing the square would give us e to the x minus 3 squared minus 9, and then we've got that plus 1 still, or e to the x minus 3 squared equal to 8, giving us e to the x equals 3 plus or minus 2 root 2. Taking the natural log of both sides, this would give us x equal the natural log of 3 plus or minus 2 root 2. As we can see on the graph, we are expecting two solutions, and we'll note that these are the negative of each other. So in other words, what we're saying is that ln of 3 plus 2 root 2 equals minus the natural log of 3 minus 2 root 2. If you were to add these two terms together, you would see that it came to being the natural log of 1, or in other words 0. You may wish to try this for yourself to check the result. In this example here, we will also rewrite cosh x and 2 sinh x in their exponential form. So e to the x plus e to the minus x over 2 plus 2 of e to the x minus e to the minus x over 2 equal to 3. If we multiply up by 2 and by e to the x again and rearrange, then we would have that we have 3 e to the x squared minus 6 e to the x minus 1 equal to 0. So another quadratic, and we can solve this by a choice of method or even by calculator. Here I'm going to use the quadratic equation, which would give me 6 plus or minus the square root of 36 plus 12 all over 6 equal to 1 plus or minus 2 root 3 over 3. In the last example, by considering the graph, we were happy that there were two real solutions. However, consideration of this graph, where we see that the line y equals 3 and the graph of cosh x plus 2 sin x only has one intersection would lead us to look again very carefully at the solutions. In this case, 1 minus 2 root 3 over 3 would be less than 0, and we know that e to the x must be greater than 0 and that the natural log values are only valid for positive numbers. Hence the one solution is x equals the natural log of 1 plus 2 root 3 over 3. Note that there is a difference to solving the equation and having valid solutions for the equation. In the next video, we will look at hyperbolic function identities.